I just want to quickly go through the algorithm workbench and talk about what type of loop to use. So the first one says write a while loop. So we're going to use a while loop. Trying to understand the problem is the big challenge in programming. So write a while loop. How do you understand the problem? You read through it 3-4 times. Write a while loop that lets the user enter a number. The number should be multiplied by 10 and the result assigned to a variable named product. The loop should iterate as long as product is less than 100. Well, there's your loop specification, as long as product is less than 100. So let me I'll go file, save as, test. Yeah, okay, good. So our while loop is obvious. While product is less than 100. We want to ask the user to enter a number. Number equals int input, enter a number, right? Okay. The problem is, and then we say product equals number times 10. I think that's what it says. The number should be multiplied by 10. So there we go. As long as product is less than 100, we're going to repeat this. Problem is, we can't use product in our while loop until product is assigned a value. Now, we could put it product equals 0, and that would probably work. But the better way is to prime the loop and do this outside of the loop before you enter the while loop. It's the preferred method by the author, that you prime the loop first and give product a value, and then as long as it's less than 100, it'll repeat. So let's watch this work. So I'll enter a number 200. Well, that's not less than, the product is 2000, so that's not less than 100. If I enter a number 1 or 5 or 50, quits because the product would be 500, right? So that's essentially the answer to that, is because we don't have to print out the product, I don't think. The loop should iterate as long as the product is less than 100. Well, I guess I could print product out here. Product is, comma, product. And that'll print it out before it asks again. But it won't print it out if he puts in an invalid value right away. So, well, let's see how it works. Enter number 5, product is 50. Enter number 9, product is 90. Enter product number 10, and it doesn't do anything, which is fine. So if I put in 10 right away, it doesn't print anything out, because it only prints out as long as the product is less than 100. So that's okay. That works. Write a while loop that asks the user to enter 2 numbers. The numbers should be added and the sum displayed. The loop should ask the user if he or she wants to perform the operation again. Okay, there's a good example in the textbook asking the user, do you want to do it again? Yes or no? So look at that example and figure out how to do this. Ask the user to enter 2 numbers. They are added together and the sum displayed. So check out the code, the example in the textbook on how to do that. Write a for loop that displays the following set of numbers. Okay, 0, 10, 20. So it starts at 0, it goes to 1,000. So if it's going up by 10, so you'll use a step value of 10, and you'll have to go to 1,010, so that you include 1,000 in your range statement. Okay, write a loop that asks the user to enter a number. The number should iterate 10 times and keep a routing total of the numbers entered. So it's going to iterate 10 times. So our for loop should be, does it say we have to use a for loop? No, it doesn't say we have to use a for loop, but if we're going to iterate 10 times, you know, for x in range 10. That iterates 10 times. Keeps a running total of the numbers entered. So you just say num equals enter a number, and total plus equals x. Num, not x. I'm not using x. X is just my my loop counter so that I do this 10 times. And you always have to initialize total to 0, right, when you're doing an accumulator. So this is where you get the input from the user. Input, enter a number. Okay? So that's how you do that one for. Now the next one's interesting. I like this next one. Write a loop that calculates the following series of numbers. Okay. So we have a numerator that goes from 1 to 30. We have a denominator that goes from 30 down to 1. Well, I would loop based on the numerator. I would say numerator in range 1 to 31. Right? That's easy to do. For numerator in range 1 comma 31. Right? That'll go from 1 to 31. Your denominator starts at 30 and goes down by 1 each time. So really, all you have to do is say denominator, initialize it to 30, and in here you just sum plus equals numerator divided by denominator. And decrement your denominator. I think I spelled it wrong, but I don't care. How do you decrement? Denominator minus equals 1. So that'll calculate that total. And don't forget you have to initialize sum up here. Looks like summer is a keyword. I'll say summer. There. So summer equals 0. And that should work. That's that one. Rewrite the statements using augmented operators. It's a simple look in the textbook for that. Write a set of nested loops that displays 10 rows of the pound character. There should be 15 in each row. This is a nested loop, and it's covered very well just a little bit before the end of the chapter. And right here is a nice nested loop where we have rows and columns. We've got 1, 2, 3, 4, 5 rows. So we're going to do range in rows. Well, this asks how many rows. In this case, we said 5. So it's going to do 5 rows. So the outer loop goes 5 times. The inner loop is the printing out of the asterisks, where we print out an asterisk each time inside the inner loop, and we don't do a new line. So we suppress the new line character. So we get these inner asterisks on one row. So the inner loop iterates the number of columns times. In this case, it looks like it's 10 columns. And then we iterate the outer loop, because the inner loop must iterate through its entirety for each iteration of the outer loop. So after we finish iterating our outer loop, our inner loop, we print a blank line in order to get the new line character down to the next line. Another one is this triangular pattern, and it's shown how to do here. The outer loop starts at 1. So we're going to do this 8 times, and our outer loop goes for r in range 8. So r is 0 to begin with, right? It goes from 0 to 7. So it starts at 0, and our inner loop iterates for c in range 0 plus 1, which is 1. So the inner loop will iterate once the first time through. Then we iterate our outer loop, so r goes from 0 to 1, and then our inner loop for c in range 2. So we're going to iterate the inner loop 2 times. And again, print the blank line, or print just to get the cursor down to the next line. Okay, so that's nested loops. You need to really study that one. It's important that you understand that for the next test that we're coming up to. Prompts the user to enter positive non-zero and validates the input. Okay, positive non-zero. So it's got to be greater than 0. So the standard way is first thing you do, enter a number. Always have to prime the loop where you say num equals int input, enter a number, and then we go while the number is, now when we're validating, it validates the input. So if he enters something that's invalid, so if he enters something that num is less than 1 or num greater than 100, right? That's invalid, range of 1 to 100. So less than 1 or greater than 100 is invalid. So test for invalid. So if it's invalid, we want to repeat, and we want to say print, actually print that was invalid, and then we can just duplicate our input statement down here and ask them to enter a number. So when we run it, we say if we go 200, that number was invalid. 100, that's good. Enter a number, -5, that number was invalid. 50, that's good. Okay, so as long as the number is invalid, as long as it's less than 1 or greater than 100, we'll repeat this loop. That's validation. It's covered in the textbook as well. Write code that prompts you. Oh, that's it? Oh, we're done. Oh, enter positive. Oh, positive non-zero. So that one's greater than 0. This one's 1 to 100. So it's just different ranges for validation. Okay.